At the end of the previous lesson, we spoke briefly about how we could attempt to compute the range of a projectile that is launched from an incline using a different approach. In this lesson, we will set up the foundation for this new approach. And let's actually compute the range using this alternate approach in the next lesson. But this requires you to change your perspective or mindset just a little bit. It may seem a little inconvenient the first time you get introduced to it, but believe me, once you are used to it, you will start to enjoy the benefits. Up until now, we've always thought of the x-axis as being horizontal and the y-axis as being vertical. But the x-axis and the y-axis need not be horizontal and vertical, but the necessary condition is that they need to be perpendicular to each other. So instead of the x-axis being horizontal, let's try aligning the x-axis with the plane of the incline. That way, the y-axis will be perpendicular to the incline. Let's just see this in animation so we are very clear on this. What we do is to rotate the coordinate system until the x-axis, which was horizontal, is now aligned with the plane of the incline, and therefore the y-axis will be perpendicular to the incline. And in a sense, the problem appears like it did before, meaning that the projectile is launched from the x-axis and will land back on the x-axis. But in rotating the axes, there are changes which come about as a consequence, and we will see how to deal with that. Now we perform the same kind of steps that we had in the absence of the incline, and we begin by resolving the initial velocity vector v0 along the x-axis and along the y-axis. But as you perform these steps, always bear in mind that the new rotated coordinate system has the x-axis along the incline and the y-axis perpendicular to the incline. Therefore, Vx, or the x component of velocity, will lie along the incline and will no longer be horizontal, and Vy, the y component of initial velocity, will be perpendicular to the incline and not vertical as earlier. So then Vx would be V0 times cos of alpha, and Vy will be V0 times sine of alpha, where alpha is the launch angle with respect to the incline. Remember now that Vx and Vy will no longer be parallel and perpendicular to the ground, but would be to the plane of the incline. So the initial velocity components change here accordingly. But what about the acceleration? Would that also change? The acceleration due to gravity will keep acting downwards, whether an incline is present or not. But when the x and y axes were horizontal and vertical respectively, since a vertical vector will not have any horizontal component, we took advantage of the fact that there was no horizontal acceleration. But now our axes have been rotated. So we would have to resolve the gravitational acceleration g along the new x-axis, along the incline, and along the new y-axis perpendicular to the incline. And as you can see, the component along the x-axis will be g sine beta, which would point in the opposite direction to the initial velocity vector vx. And the component along the y-axis will be g cos beta, which would point in the opposite direction to the initial velocity vector vy. This is a table which shows you the new initial velocity and acceleration vector components along the newly rotated axes. This table gives us just the magnitudes and not the signs. But now, along the x-axis, the initial velocity vector will be v0 cos of alpha, pointing upwards along the incline, and the acceleration along the incline will be g sine beta in a direction opposing the initial velocity vector. And along the y-axis, the initial velocity vector will be v0 sine of alpha, pointing upwards perpendicular to the incline, and the acceleration perpendicular to the incline will be g cos beta in a direction opposing the initial velocity. This is what you have to be aware of in dealing with projectile launches on an incline. The rest of the procedure remains the same, but you would have realized that when there was no incline, that the coordinate system was horizontal and vertical, and the acceleration along the x-axis was 0 as beta is then 0, which made things easier for us, but we lose that advantage here. In the next lesson, we will use the concept that we have learned here to obtain the range of a projectile that is launched from an incline. And from this point on, we will apply only the equations of motion along each axis. And then you can compare this approach with the one in the previous lesson, where we used the trajectory equation to do the same. We rotate the coordinate system such that the x-axis aligns with the plane of the incline and the y-axis is perpendicular to the plane of the incline. We then have to resolve the initial velocity vector and the gravitational acceleration vector along the new rotated axes.